Assalamu alaikum students. Our today's lecture is about the switching networks, and we would refer to chapter number 5 of our textbook Telecommunications, Switching, Traffic and Networks by J.E. Flood. Uh, uh, we need to design a network which has a greater number of outlets than the switches from which they are built. What does that mean? There would be a certain number of inlets and a certain number of outlets to a network. What we want is to allow a very large number of sources, which means that a very large number of customers can be connected to this one single exchange, and and we can offer them a facility to get connected to any other number they want around the world, and that particular number can be a landline number or a mobile number. So first of all, we can see what are single stage networks. A single stage network would be the one in which we have a certain number of inlets and a certain number of outlets, and they are connected and through some cross points, and the number of cross points would be equal to the multiple of the number of inlets and the number of outlets. If the number of inlets is m and the number of outlets is n, then the total number of cross points, or the cross point matrix in the cross point matrix, would be m into n. We can refer to chapter number 3 of this book to see such an example. Here it is. This is the matrix of cross points given on figure 3.11. You can see that we have certain number m inlets and a certain number n outlets, and we have got m into n number of cross points which allow us to get connected to connect the inlets to the outlets. In this switch, the situation is that one of the inlets wants to get an access to an outlet. So it has multiple options of going out. Where it has to go out, that is defined by the stored program control, and the stored program control gets the information or gets the its command from the dialed number. The dialed number defines which outlet it has to take. These cross points, in this case, you can see that we can have an AND gate in this case also, while the stored program control stays somewhere above this, and it controls which outlet is allocated to which inlet. Let's move back to our main topic. If we see one single cross point, it would be defined like this. It has two symbols. It can be shown like this: m into n and also m into n. These are the two different symbols for the switch. So what would happen if we have m inlets and n outlets? The total number of cross points required for such a system would be n into n. while in case of in a case when the number of inlets is equal to the number of outlets, then the total number of cross points required would be n square, because m is equal to n. But if this is the case, then let's see what is the efficiency of such a system. The total number of calls that can be made at a certain point of time. In such a case, if it is, for example, if we have got 10 inlets and 10 outlets, then the total number of cross points would be 100, 10 into 10. But at the maximum, only 10 calls can be made at one time. So the efficiency would be 10 over 100, which is 10%. Only 10% calls can be made, right? By using this system. We cannot have more than 10 calls at a certain point in time. So at a certain point of time, the number of cross points that can be used is n divided by n square. So the efficiency would be 1 over n. So as we increase the value of n, the efficiency decreases. So it is an uneconomic way of using the system. So single stage networks are not an efficient way of providing switching. Now, what would happen, for example, a switch with 100 inlets and 100 inlets and outlets requires 10,000 cross points, and only 1% of these can be in use at any time. So switches for making connections between large number of trunks are therefore constructed as networks containing several stages of networks. We can try one more thing. Instead of using m into n as the number of cross points, we can have triangular cross point matrix for connecting both way trunks, incoming and outgoing, which is shown in figure 5.2. You can see this in figure 5.2 here. Here we have removed the upper diagonal, the cross points above the diagonal of this matrix. Upper half is removed, so half of them are remaining. So what would happen is that the total number of cross points would be 1 over 2 into n minus 1. So the total number of cross points has reduced almost half as compared to this value. Here C1 represents a single stage network. C is the number of cross points for a single stage network, which we found that it was n square, but if we remove the cross points from the upper half of the matrix above the diagonal, then we are left with this value. C1 is equal to 1 over 2 n into n minus 1. You can see this equation. So we have improved the efficiency a little bit, but that does not solve our problem, because we need to offer the service to a very large number of customers. For example, in a landline exchange, there are approximately 100,000 lines connected to that switch. Then if we provide try to provide them with a single stage network, the number of cross points required would be very high. Let me remind you that the number of cross points is the basic ingredient of the exchange that participates. That is the dynamic part of the cost or the price of an exchange. The other parts or the other factors which contribute to the price of an exchange are normally static or passive. For example, the similar infrastructure, air conditioning, stored program control would be required, while the number of cross points is the main factor that affects the number of the number the amount of the cost of the cost of the exchange. So the finding out the number of cross points is very important. Now what we do is that we make our exchanges in the form of in steps. So we have certain steps of selection which are basically defined by the telephone numbers.